but we're going to focus on some new wording and how to tackle those. So we're focusing on the parallel and perpendicular slopes that I mentioned in the last video. I have my examples there still. So moving forward, let's check out what we have. Parallel lines is where we're going to start. These lines have the same slopes, so just keep that in mind. So the wording of these problems looks like this. I'm asking you to write the equation of a line that goes through the points 8, -5, and that is parallel to the given line. Y equals -5/2 x plus 5. You're definitely going to use this point. I'm telling you it's going through the point. You need at least the slope to figure it out. Parallel lines have the same slope, so you just need to figure out what the slope is of this line. The slope is -5/2. And then once you have that, and you're kind of focused on this point, you have what we did in the last video. So we can go ahead and plug this in. Again, I personally like point slope form, so you'll see me use that a lot. So I'm going to go y minus 5 equals -5/2 times x minus 8. Distribute the 5/2. A little trickier here with this one. -5/2 x is easy in the beginning. Negative times a negative, we know we at least have a positive here. When you're multiplying fractions, remember it just ends up being like a 40/2, which ends up being a positive 20. So we have that. Add 5 to both sides to finish it out, and we have our parallel equation. Again, parallel equations, all they have is the same slope. They have the same slope, we're good to go. Let's look at a second one. Same type of wording, except my equation is now in standard form. So remember here, it'd be nice if we remembered our shortcut. Our slope is -a/b. All I want to know from this line is what is the slope. I don't care about the rest. My slope happens to be -2 over -3, which simplifies down to 2/3. So the slope I'm going to use is 2/3. The point I'm going to use is 3, -1. And I go ahead and plug it in from here and finish finding the equation. So we have y plus 1 minus -1 is what it was, equals 2/3 x times x minus 3, distribute y plus 1 equals 2/3 x minus 2. Subtract 1 from both sides. And you're all set. Next two and last two, we're dealing with perpendicular lines. Same wording, just changing the symbol. We're writing the equation of the line that goes through the point -5, -1, and that is perpendicular to y equals x plus 5. Now, the slope of this line is just 1. I don't need the exact slope because we're not looking at parallel lines where they're the same slope. I need perpendicular slope, which is the opposite reciprocal. Opposite, you flip 1, it stays 1. This is the slope I need. That's what I'm going to use, along with the point -5, -1. Go ahead and plug those in, just like I've been doing. Y plus 1 equals -1 times x plus 5. Make sure it's minus a negative. That's why that's all changing there. -x minus 5, subtract 1, y equals -x minus 6. That's my equation. Opposite reciprocal is the bigger deal on these ones. Final example. Standard form once again, just like the last slide. Again, all I care about is what the slope is, and then I tweak it from there. So the slope, again, shortcut negative a over b. So we have negative 4 over 1. But my perpendicular slope, opposite sign, so it's positive 1 over 4. That's what I'm using. I'm also using the point 4, negative 1. Plug everything in. X1, Y1. Y plus 1 equals 1/4 times X minus 4. Distribute. So we have that. Subtract 1 for both sides. And we're done.